Welcome to Danny's Maths Hub, and today we are going to look at angles in parallel lines. Now, before we do, there are some key words that you'll need to know for today's lesson, and that's corresponding, alternate, co-interior, and vertically opposite. Now, I'm going to go through and explain what each of these means. Now, they all have a meaning when we talk about angles in parallel lines, and more specifically, the angles that are formed when we draw a line through to a pair of parallel lines. If you can see here, the blue lines are our parallel lines, and they are often shown to us as being parallel with this notation on them. Two arrows pointing the same way, that tells us it's parallel. If we draw a straight line through a pair of parallel lines, 8 angles are formed. 1, 2, 3, 4, 5, 6, 7, 8. Whilst there are 8 angles, actually they only create 2 different sized angles, an acute angle, which is less than 90 degrees, and an obtuse angle, which is greater than 90 degrees. Now, in some cases, it can create 8 right angles, but that's only in one special case. So if we actually look at these angles, this angle here is our obtuse angle, and it's going to be the same size angle as all the other obtuse angles that were formed. And if we look at all the acute angles that have been formed, all these acute angles are also going to be exactly the same size. Now, it's the pairs of angles that have these special names. 2 angles on the same side of the drawn line, such as these 2 red ones, we call corresponding. Now, they're corresponding if they are the same size and on the same side as the drawn line. Equally, these 2 blue ones are corresponding, these 2 red ones are corresponding, and these 2 blue ones are also corresponding, because they're the same size and on the same side of the drawn line. Now, if angles are equal but on different sides of the drawn line, for instance, this red angle here and this red angle here, they're the same size because they're both obtuse. However, they're on different sides of the drawn line, so we call them alternate angles. This blue angle here is alternate with this. This red angle here is alternate with this one. And this blue angle here is alternate with this blue angle. The same size angles but on different sides of the drawn line. Now, what we have is vertically opposite angles as well. And these are the 2 angles that sit directly opposite each other around the same point. So this point that's formed here, these 2 red ones here and here, they are vertically opposite. These 2 blue ones are vertically opposite because they are the same sized angles and around the same point. Same over here. This angle is the same size as this angle, so they're vertically opposite because they're around the same point. This and this are vertically opposite because they're the same size and around the same point. And the last special word we need is co-interior. Now, these 2 angles are not the same size. However, there is still something special about them. These 2 angles here will always add up to 180 degrees. And these 2 angles here will always add up to 180 degrees. Now, that's when we call them co-interior. If they're inside the parallel lines, okay, and the same side of the drawn line, well, they'll add up to 180, and we call them co-interior. You can see this pair is inside the parallel lines here, and this pair are inside the parallel lines here. And they add together to make us 180. We can see that that's true because the blue and the red one here are on a straight line, and they add up to 180. So let's have a look at some questions. Imagine if we were told that this angle here was 75 degrees. Well, then we'd know that this one was 75 degrees as well, and that would be vertically opposite. We know that this one would be 75 degrees as well, and it would be corresponding with this one. And we know that this one would also be 75 degrees, because it's alternate angles to this one. They're the same size, but on a different side of the line. Well, if we know that this is 75, then we could work out that this one here is 105. Because they're on a straight line, so they have to add up to 180, which means this one would be vertically opposite to that one. This one would be corresponding with that, and this one would be alternate to that. So this is how we use what we've learned and those special words in questions. For example, if we wanted to work out what A, B, C, D, E, F, and H are, well, first of all, we can work out exactly what all the obtuse ones are. This is 135 because it's vertically opposite. This one's 135 because it's corresponding, and this one is 135 because it's alternate angles. We can work out what A is because this is a straight line here, So 180 minus 135 is 45 degrees, which means C would have to be 45 degrees because it's vertically opposite. E would have to be 45 degrees because it's corresponding with A. And H would be 45 degrees because it's an alternate angle with A. Now here we have two drawn lines. So we've got to be careful which ones we link with what. If we wanted to find out what C was, well, C is nice and easy. It's the same size, it's an acute angle around the same point, so this would be 25. D would also be 25 because it's corresponding with this. Now, E, A and B cannot be found using this piece of information because it's on a different drawn line. However, we can work out what E is. E is 120 because it's vertically opposite. B is 120 because it's corresponding. And A would also be 120 because it's alternate. Now, how could we possibly find what F is? Now, this question we need to use a different rule. We'd have to use the rules of our triangles. Look at this. This creates a triangle here. And we can work out what this angle is because it's vertically opposite to 25 here. So we know that this angle would be 25, but we could work out what this angle here is as well because it's on a straight line with 120, so this is 60. So we could work out what this angle is because we know angles in a triangle add up to 180. But if we've already got 85, 180 minus 85 would give us 95, which means this angle here is 95. And now we need to use a different angle fact. We now need to look at angles around a point. Well, we know this angle here is 95. So how can we work out what the rest of this angle is? Well, we should have 360 around a point. If we minus 95, we end up with 265 degrees, which means F is 265 degrees. Now you'll notice throughout that question, I kept using the language of corresponding alternate, vertically opposite, angles on a straight line, angles in a triangle. And that's vital. If you're given a question like this, 9 times out of 10, what will follow is give reasons for your answer. And that's when you have to use that language I was just saying. So if your question actually defined A, B, and C, it should be quite easy to do. A is angles on a straight line, so we know that this is 77 degrees. B is corresponding with 103, so we know that this is going to be 103. And C is corresponding with A, so that'd be 77. But we'd have to give reasons. So our reasons for A is exactly what I said, angles on a straight line. The reason B is 103 is because of the reason I said, corresponding angles. And the reason C is 77, again, is for the reason I said, because A and C are corresponding. If you're asked to give a reason, that's what you have to say. You have to give whether it's corresponding, alternate, vertically opposite, on a straight line, angles in a triangle. And there's always extra marks up for grabs for that. So don't forget, if you're asked to give a reason, we've got to say one of these special key words. Very well done for taking your time to watch this video. Please click the link below to go straight to a worksheet. And also, if you complete that worksheet, then there's another video where I've gone through all the answers if you're a little bit confused about where some of the answers come from. Well done, and until the next time, stay safe.